All right, what questions do we have today?
Can you do a problem that's similar to the homework problem that says, or do you need me to read it to you, or do you have it?
How about if I just do the homework problem? Which one do you need me to do?
Oh. Find f of negative 3 if the f of x is 1/2 5 to the x
Okay,
plus
so
1.
wait a minute. I
Yes,
gotta
I'm-
find my homework paper. Here we go. So it's number 2.
Yeah.
So I need to do 1/2 times 5 to the negative 3 plus 1. Like any function, you're just plugging in negative 3 for x. So when I plug in negative 3 for x, my exponent becomes negative 2. Now, I need to remember how negative exponents are handled. What does 5 to the negative second mean?
Does it put 5 under 1?
It does. It becomes 1/2 times 1/5 to the second. Negative exponents are flips. You flip it over, the number over, so 5 becomes 1/5. And then, of course, 1/5 squared is 1/25. So our answer is 1/50.
Thank you.
Mm-hmm. What else do we have?
I don't understand number 3.
On the homework?
Yeah.
Okay, that's going to be on the quiz too. And we did several problems, Shania, like this, and I don't believe you've watched the video yet, have you?
I watched it, but I didn't understand it. That's why I got on the flex.
Okay. Okay. You need to be in class because you do not do very well when you're not here. So work real hard to be in class, okay? End behavior is the limit as we approach positive infinity, that is going right, and as we go left. So the first thing we need to do is get a visual of what this curve would look like if I graphed it. So if I graph it, I can see it's a decay because this number is less than 1. So that curve is going to be decaying. As I go to the right then, it just keeps coming down, getting closer and closer to 0. From the top, it's coming down, getting closer and closer to 0. As I go to the left, though, as I draw my picture to the left, it's just going up into forever. It's going up to infinity.
So do we not put the negative sign on top of the infinity since it's from the left?
Wait. Now wait. This number describes what this curve is doing. Why would there be any negatives? What is this thing doing? What are these y values doing?
It's going up.
Uh-huh. Period.
Okay.
I mean, I'm not sure what you're thinking, but don't try to like memorize something. Just look at the picture and describe what the picture's doing. It's going up forever and ever and ever, bigger and bigger positive. There's no negative involved in that. Now, there is down here in the notation, because x is going to the left. We're talking about going to the left. These are the end behavior notations. That will always be the same for every problem. But these numbers over here, you're just looking at your picture and writing down what's happening.
Okay.
Okay.
I get it.
You got to start with the picture, though. Draw the picture first.
And then if the number in the parentheses was over 1,
Then the curve would look like this.
Okay, it makes sense now.
You would answer the same questions, but you would be using that picture. which is a growth picture. So if this were like 4/3, that would be this picture,
Okay.
okay? What else? Particularly maybe from the quiz practice problems that I gave you. Which that was one of them, actually.
Can we do another one like the fourth quiz problem?
Nope, oh, it is. Okay, so a logistic function. Well, we just wrote a whole bunch of them. So like we just wrote, I don't remember what it was, but we just wrote a logistic function. It was something like, I don't know, 128 over 1 plus 7 times 0.38 to this x. I'm making that up, I don't know, but that's a logistic function. So the two questions were on the practice quiz, which I just had, there it is. The two questions were, what is the initial value and what's the maximum value? The maximum value is right there. So that is easy. That's the limit to growth. That would be where your top asymptote would be if we were drawing a picture of it, which we're not, but that would be the top horizontal asymptote. Now, the initial value, we talked about it, several different kinds of problems. It is the y-intercept. It is the y value when x is 0. So you're going to come back over to your equation and you're going to let x be 0. And if x is 0, then we have 128 over 1 plus 7, because that becomes 1. This just becomes 1. So we have 128 divided by 8, which is something, 16. So your initial value is 16. Your initial value is the value that you get when you plug in 0 for x. It's the same as the y-intercept. Okay? So if we look at our homework problem number 4, it is very, the questions are worded a little bit differently, but it's exactly the same idea. Because if our equation is 16 over 1 plus 2 times 0.7 to the x, then our y-intercept is the same as the initial value, and it is this point right here. So we'll put 0, get this out of here. We'll put 0 in for x, because that's what we do to find the y-intercept or the initial value. Either one, they're exactly the same thing. So I'm going to put 0 in, and if I put 0 in here, then this goes away, or becomes 1, basically goes away, and I have 16 over 1 plus 2, so I have 16/3. So my y-intercept, or my initial value, is 16/3. Now, one slight difference is, if you're asked for the y-intercept, you need to list a point. If you're asked for the initial value, it would just be 16/3. But the work is all the same. And then it says, what are the asymptotes? Well, remember, a logistic function has a top asymptote and a bottom asymptote. Unless you have done something funky to the problem, the bottom asymptote's going to be at 0. And we know by looking at the problem, where's the top asymptote? What's the maximum value?
Is it 16?
Yes.
So it'll be 0 in whatever the top is because it's over 1.
Yep.
Right? Yeah, I'm thinking too hard into it.
All right, is that it?
Yes, that's it. Thank you.
You're welcome. Have a good day.
You too.